Hey, can you really survive a black hole? Like, if a spaceship got too close, would the people inside just get sucked in and that's it?
That's a super exciting question, and it's one that makes scientists scratch their heads too. But to figure out if survival is possible, we gotta start with the basics. What exactly is a black hole? It's not like a big empty hole in space that you could fall through like a tunnel in a cartoon. Imagine the sun, our big bright star that's kept Earth warm for billions of years. Now picture it running out of fuel after a really long time, like an old car that finally breaks down. When a massive star like that dies, it doesn't just fade away quietly. It collapses in on itself with a huge crunch, squishing all that star stuff into a tiny spot that's super dense. Way smaller than a city, but with the mass of a whole star.
Collapses. So it's like the star shrinking down really small.
Exactly. That collapse creates something wild. Gravity so strong that it warps space and time around it, like how a heavy bowling ball on a trampoline bends the fabric and pulls marbles toward it. But this is on a cosmic scale. The black hole's gravity is so intense that it bends light itself, and that's why we can't see it directly. Light is the fastest thing in the universe, right? If even light can't escape being pulled in, the black hole stays hidden, like a shadow that swallows everything. We only spot them by watching how they tug on nearby stars or gas clouds, making them whip around super fast.
Invisible because it eats light? That's kind of spooky, like a monster in the dark. But if it's from a dying star, do all stars turn into black holes?
Not all of them, thankfully. Our sun, for example, is too small and lightweight. When it dies in about 5 billion years, it'll puff up into a red giant and then shrink into a white dwarf, like a hot ember cooling off. Black holes form from the really massive stars, ones at least 20 times bigger than our sun. When they explode in a supernova, that's like the star's grand finale, blasting out light brighter than a billion suns. The core left behind can collapse into a black hole if it's heavy enough. It's nature's way of recycling, but extreme. Think of it like squishing a whole playground full of kids' toys into a marble. Everything gets packed so tight that the rules of normal space break down.
Whoa, a supernova explosion sounds awesome. So black holes are these gravity traps from dead stars. But isn't it just an empty hole, like nothing's there?
Nope, not empty at all. At the center, there's a singularity. That's the superdense point where all the star's mass is crammed, and gravity goes infinite, meaning infinitely strong. Around it is a region where space-time is so warped it's like a one-way door. We call the whole thing a black hole because from far away it looks black against the stars. Scientists first predicted them over 100 years ago with Einstein's theory of gravity, and now we see evidence everywhere, like the one at the center of our galaxy, Sagittarius A star, which is 4 million times the Sun's mass, but squeezed into a space smaller than our solar system.
Einstein? He was the guy with the wild hair, right? Okay, so they're real and super powerful. But if the gravity is that strong, can anything get close without falling in forever?
Yeah, Einstein was the genius with the crazy hair who figured out how gravity really works. It's not just a force pulling things down, but a curve in space itself. And you're spot on. Getting close to a black hole is tricky because of something called the event horizon. That's like an invisible line around the black hole, the point of no return. Imagine you're on a roller coaster that's speeding up faster and faster as it drops. To escape, you'd need to go quicker than anything possible. Near the event horizon, the gravity is so intense that the speed you'd need to break free, called escape velocity, becomes greater than the speed of light. Light zips along at 186,000 miles per second, the universe's speed limit. If even light can't outrun the pull and get away, Nothing else can either.
The speed of light. So, like, if I shine a flashlight toward a black hole from just outside that line, the beam just stops and falls in?
Pretty much. Once light crosses the event horizon, it's trapped forever, heading straight for the singularity at the center. That's why the black hole looks black. No light bounces back to our eyes. Think of it like a waterfall in a river. You can swim upstream against the current if you're strong enough, but past a certain point, the water rushes so fast that even the strongest swimmer gets swept over the edge. The event horizon is that cosmic waterfall edge for gravity. Anything that crosses it, whether it's a spaceship, a rock, or you, is doomed to spiral in. Scientists call it a boundary in space-time, and it's not a physical wall. It's just where the rules change so drastically that escape is impossible.
Whoa. So no turning back once you're over that line. But why can't light just speed away? Isn't it the fastest?
Great question. Light is the fastest, but gravity near a black hole doesn't just pull. It warps the path light takes. According to Einstein, space and time bend around massive objects, like how a magnet bends iron filings. For a black hole, the warping is extreme, curving space so steeply that all paths lead inward past the horizon. Even if light tries to go straight, the straight path loops back in. We've seen this in action with real black holes. Telescopes like the Event Horizon Telescope captured the glow around one in 2019, showing a dark shadow where light can't escape. It's like being inside a bubble where every door leads to the same room, the black hole's core.
That picture they took, it looked like a donut of fire around a black spot. So if a spaceship hovered right at the edge, could it peek in without crossing?
Hovering right at the edge is tough because the gravity gradient, the way pull changes over distance, is so steep. Your spaceship's engines would have to fight harder and harder the closer you get, needing infinite power to stay put exactly on the horizon. In practice, you'd either fall in or get flung away if you're orbiting. But yeah, from a safe orbit outside, you could watch stuff disappear, like stars' light flickering out as they cross. It's a one-way trip. No U-turns allowed by the laws of physics.
Infinite power? That's impossible. Okay, so the event horizon is like the ultimate trapdoor. But what would actually happen if something, like a person, crossed that line?
Crossing that line would be a wild, terrifying ride, and not in a fun amusement park way. As you approach the event horizon, the black hole's gravity starts pulling on different parts of your body unevenly. That's called tidal forces. Picture yourself as a long rope being tugged harder at one end than the other. Your feet, closer to the black hole, get yanked way stronger than your head, so you'd start stretching out like taffy being pulled in two directions. Scientists even have a funny name for it, spaghettification. It's not gentle, it happens fast, ripping you apart molecule by molecule before you even fully cross.
Spaghettification? Like turning into spaghetti? That sounds painful. Would it pull you in slowly, like a vacuum cleaner sucking up dust?
Nope, not slow at all. It's more like getting caught in a super strong current that accelerates you toward doom. For a small black hole, say one from a star like we talked about, the tidal forces kick in early, even before the horizon. Your body would feel the stretch right away as you fall in. Bones cracking, skin tearing, like being pulled through a giant pasta maker. It'd hurt a ton, and you'd be torn to shreds in seconds. But for a huge, supermassive black hole, like the one in our galaxy's center, the horizon is bigger, so the pull feels more even at first. You might cross without noticing the stretch immediately. But once inside, there's no escape. And the real crushing comes later.
Crushing? So it doesn't just stretch you. What else happens deeper in?
Yeah, deeper toward the singularity, the heart of the black hole. Everything gets squeezed insanely tight. All that mass packed into a pinpoint creates pressures beyond imagination, like trying to fit the entire Earth's weight into a speck of dust. Your atoms would smash together, electrons ripped from protons, until you're not even matter anymore, just energy spiraling in. It's total disintegration. No part of you survives intact. Time itself warps so much that from outside, you'd seem to freeze at the horizon. But to you, the plunge feels quick and final. We've run computer simulations of this, and they all show the same brutal end. No Hollywood slow-motion float.
Yikes, that's way scarier than any monster movie. So, does it hurt the whole time, or is it over fast?
For most black holes, the pain wouldn't last long because the destruction is so rapid, your nerves couldn't even process it fully before you're gone. It's like falling off a cliff. The wind rush is intense, but the end comes quick. But imagine a kid dropping a toy into a shredder. The toy doesn't feel the blades one by one, it just vanishes in a whirl. That's you near a black hole. The forces are so overwhelming that survival isn't just hard, it's physically impossible for anything made of normal stuff like us.
No wonder nobody's tried visiting one. If it's that bad, stretching and smashing everything, is there maybe some super tech in the future that could protect us from it?
Dreaming up future tech to battle a black hole. That's the stuff of epic sci-fi movies, isn't it? Like imagining a shield that bounces away the gravity, or engines that zoom faster than light. But let's think this through step by step. The big problem isn't just getting close. It's what happens once you're past that event horizon we talked about. Physics, the rules that govern everything in the universe, says no tech can beat that. It's like trying to swim out of a whirlpool by paddling harder. The water's pull wins every time, because it's built into how the pool works.
So even a super fast spaceship couldn't outrun it? Like, what if it had rocket boosters 1,000,000 times stronger?
1,000,000 times stronger sounds awesome, like turning your bike into a jet-powered speedster. But here's the catch. Inside the event horizon, space itself is falling inward faster than light can travel outward. No matter how powerful your engines, you're carried along with the flow, like leaves in a raging river. Scientists have crunched the numbers using Einstein's equations, and they all point to the same thing. Escape velocity there is impossible. Even if we invented warp drives or wormholes someday, those ideas still bend around the horizon without crossing it. You can't fight infinite gravity. It's not a wall you punch through. It's the fabric of reality twisting shut behind you.
Warp drives? Those are the ones that fold space like origami, right? But if they can't get past, what about a force field? Like an invisible bubble that keeps the tidal forces out?
Origami space. Love that image. Yeah, warp drives are a cool theory for shortcutting across the stars, but they'd fizzle near a black hole because the warping gets hijacked by the black hole's own bend. As for force fields, picture one like a superhero's energy dome. In theory, maybe it could shield against radiation or small pulls, but tidal forces? They're not a push from outside. They stretch you from within, unevenly yanking your toes versus your nose. No bubble holds that. It'd rip apart like wet paper in a storm. We've got tech today that handles extreme gravity, like satellites orbiting Earth. But scaling up to black hole levels? Nope. Quantum physics hints at wild stuff like Hawking radiation, where black holes slowly evaporate over eons, but that's not a rescue plan for anything falling in.
Hawking radiation? Is that like the black hole sweating out bits to shrink?
Exactly. like a hot coal slowly cooling by giving off steam. Stephen Hawking figured that out in the 1970s. Tiny particles pop in and out near the horizon, and some escape, making the black hole lose a smidge of mass over trillions of years. But for a human, you're vaporized way before that helps. No gadget counters the singularity's crush. It's where our laws of physics break, and we don't have tech to rewrite those rules yet. Future inventions might let us study black holes from afar, snapping pics or sending probes that orbit safely. But survival inside? The experts, from NASA to black hole hunters at Caltech, all agree. Impossible for anything we know or can imagine under current science.
So, no magic shields or speed cheats. It's like the universe has a strict no entry sign that nothing beats.
You've got it. The universe's ultimate keep-out zone. But hey, that's what makes space so thrilling. We learn by respecting these limits. Probing black holes with telescopes teaches us about gravity, stars, and even the Big Bang. You're safe here on Earth, dreaming big, without the spaghettification. Who knows, maybe one day we'll unlock more secrets. But for now, survival's off the table.
Yeah, I get it now. Black holes are too powerful. No tech can win against that pull. It's kind of cool how science shows us these wild boundaries, even if they're scary. Thanks for explaining. I won't be wishing for a black hole trip anytime soon.